All right, so this sheet has a cheat sheet how to do interval notation. Pros and cons of it. Sometimes I think that's worse than just doing examples of it, but now we can see it. So back in the olden days, this is how you guys wrote your inequalities, right? You'd say x is in between a and b and doesn't include a or b, right? Now we're going to switch that to an interval. That's not a point, it's an interval. The way I think about intervals is this. They're mini number lines. So if you were to graph x is between a and b and is not equal to them, you would have put an open dot at a and went to b and had an open dot, right? You know what I mean? If you're graphing it. Put a comma and parentheses, that's what an interval notation is. You're basically just making the number line without the line. Okay? So you might, I don't know, you may have seen these before, just like been introduced to them. But the more you use them, these are easier than dealing with signs, in my opinion. So like x is bigger than a. Well, if you had drawn that number line, you would have went to a, open dot, because not equal to, and went off to infinity, right? Jesus, please, I gotta learn to draw those. There you go. So, comma, parentheses, a to infinity. You know what I mean? So I think about it like the number line. Infinity always has a parentheses. Infinity, oh. All right. I thought you were just being a wild man. That was almost helpful. I don't know. I was seeing. Oh no. Well, the computer's working. Jiminy crickets. Jiminy crickets. We can do it. All right. So I'm not going to go through all these examples because I don't know how much screen life I have. Biggest difference is, so like, let's just do less than or equal to. So if it was less than or equal to b, you'd put a closed dot, right, at b, and then go to the left to negative infinity, right? That's it. That's your interval. But now since it's a closed dot, I'm not going to use a parentheses. I'm going to use a bracket. So bracket means you include it. That's part of it. Parentheses means it's not part of it. That's the end point. So I always use parentheses for infinity. Write that somewhere. Always parentheses for infinity. Can you include infinity? No, you can't. That's not an actual value. It's always parentheses. Now, I have seen a textbook that will use a bracket for infinity. It was actually, and it drove me absolutely insane because it's not right. It's always parentheses for infinity. All the homework answers, if it's infinity, it's going to be parentheses. Okay? All right, let's do a few examples. Bracket for including, parentheses for not including, commas were needed. Think about it like a number line. Okay? Well, actually, before we do that, I do want to, if an answer is no real numbers or no real answer, you put null set or you put no solutions. If it's all reals, actually I should go over both these. If it's all reals, you're just going from negative infinity to infinity. Because that, if you start at negative infinity and you go to infinity, that's everything. Okay. Now, if I have an or, I'm going to use this symbol. That means or. You might have done that in geometry a long time ago. The U means or, the upside down one means and. You look at it with Venn diagrams. But that would be, you're going to have two intervals. You're going to have like from A to negative infinity, or you have another one that you start at B, and you go to positive infinity. And that's how you get your two brackets. Man, I gotta learn to draw infinity. I'm just happy nothing's fallen on me yet. All right, let's do some examples. So use interval to indicate all real numbers greater than or equal to -2. So I'm going to think about this like a number line or equate. Well, all greater than or equal to -2. So if I was graphing that, I'd have a closed dot because it's equal to at -2, and greater means I'm moving to the right. So am I going to positive or negative infinity? Positive. Are you sure? Positive. Okay, I'm done pretty much with my interval notation once I graph it, right? Because what do? Add a comma, parentheses always around infinity, and then or equal to means it's a bracket. So again, this is going to be used if you take any math classes above college algebra, like pre-calc, calc, this is what is going to be used 95% of the time. If you're writing it the old school way, you said x is what? Greater than or equal to -2. So those mean the same thing, different notation. Okay. All right, so we're going to do all real numbers between -3 and 5. Between and including. What's it mean to include it? It can equal it. It can beat it. So I would say x is greater than or equal to -3, and it's less than or equal to 5, right? That's how I would do it, the old school notation. Now for interval notation, these ones are even, if it's in between, you're just going to say, well, I'm between -3 and 5, right? With brackets, because it's already equal to. Could I have done the number line thing? Yeah, you could. Dot at -3 goes to 5. Done. Comma, brackets or parentheses. It's or equal to. It's anytime I see or equal to, it's brackets. Parentheses, if it's not or equal to, or infinity, because I cannot include infinity. Okay? Yeah, good questions, good questions. All right, we'll do a lot of stuff with interval notation. All right, how about this one? Write the interval all real numbers less than or equal to -1 or greater than or equal. Do we have any that are not or equal to? Oh, we do. So this is an or. So we have two equations we're looking at, right? So all real numbers less than or equal to -1. So x is less than or equal to -1, right? Or, oh, I circled the wrong or x is greater than or equal to 1, right? Now I purposely kind of wrote those in different directions. So now, whenever I see a one-sided inequality like this, I know infinity is going to be involved, right? Because there's no endpoint. I'm only going to be able to go in one direction forever. So less than -1 means I'm going to start at -1, close dot because less than, and I'm going to the left, right? Nothing's going to stop me. I'm like a certain few running backs or quarterbacks in this room with open space. Nothing can stop them. All right. Jeez. So is that it? Is that going to be my interval? That's half of it. Just put a comma, bracket or parentheses on this one. Bracket. Yep. As or equal to. I'm going to put that symbol, okay, the union. The or symbol. The onion. No, that's not an onion. Get out of here. All right. Now my other side, I'm starting at 1, and I'm bigger than 1. So I'm going to go on the right side and go off to infinity. Comma, bracket, because it can equal 1, parentheses, because you cannot equal infinity. That's pretty much saying all real numbers except the ones in between -1 and 1, right? Because you're including everything else. When you're also doing these, you always go from smaller to larger, right? Order matters. Negative infinity is the smallest thing that can be, right? That's like how much debt I have. Don't tell my wife. All right, so I'll be like that. Never mind. I was gonna make a topical thing about like that show on Netflix. All right. All real numbers less than 2, negative style, or greater than or equal to 3. Okay. Real numbers less than 2. So that's x is less than -2. Right? Or greater than or equal to. This is what I'm going to do. How I would usually do it. Or x is greater than or equal to 3. Less than -2. Open dot. You don't have to graph these. When you do this a lot, you won't do it. But I don't know, just like I said, in my head, this is how I think about how am I going to write this? Physically, why do I write it that way? It won't hurt you to draw it every time. So I'm less than -2. And it works too, because again, that arrow goes over here. Wherever you see an arrow, that's going to be infinity, right? An arrow means it goes to infinity. Bless you. Now this one, parentheses always around infinity. -2 this time gets the parentheses. Bless you. Oh no. It's starting. Sneeze apocalypse. All right. So this one we're going to start at 3. Go off to infinity because it's greater than or equal to. And it's a parentheses and a bracket. Bracket because it's or equal to. Any questions? These are the hardest type of ones you'd ever have to do. I am missing one thing. I'll probably pick that up on the mic. All right, so how you guys feel about interval notation? Graph it, label it. That's not an eraser. This is an eraser. All right, let's get to the. That was honestly that was most of the new stuff. The rest of this should be review from here on out. So let's solve chimney crickets. Let's solve this beast. We're gonna solve some inequalities. I'm not gonna do all these. I'm gonna go through them relatively quick. These are actually straight from your book, if you're curious. But we're going to solve them and then use interval notation. That's going to be the difference. So when you are solving an inequality, what do you do different than an equality? Yeah, I don't know either. Nothing. You do them the same exact way. The only difference comes if you multiply or divide by a negative, which we're not going to do here, right? So I'm going to treat it just like any good old-fashioned algebra. What I do on one side, I can do on the other, right? Like, let's say someone in here is eating a lot of gainer, and they're bigger than someone else. If both people gain 10 pounds, the person who's bigger is still bigger, right? I can still balance that equation. So x is less than 19, right? Now that's a good answer. A great answer is going to be an interval notation. Open dot at 19. X is smaller than 19. I'm going to negative infinity. Parentheses, parentheses, because open dot. That's it. You guys think you're good if we're just adding, subtracting to solve inequalities? All right, let's get to the ones that can be a little bit more brutal. No story problems today, by the way. Try doesn't even have anything to do with it. Let's look at what happens when we have to use multiplication property. So again, treat it just like an equality. The only difference is, don't forget, if you multiply or divide by a negative to flip inequality. I won't put a sign. Okay. Now, if you had me before, I never multiply or divide by a negative. Ever. How do I do that? I'll show you. Well, let's go right to 2. So I have negative 2x minus 1 is greater than or equal to 5, right? Now, I could add 1 and then divide by negative 2, right? Instead of that, could I just add negative 2x to both sides? And then will I ever multiply or divide by negative? No. If I void that, I never have to think in my head, do I need to switch the sign or not? Does that make sense? That's good, like, test-taking advice. If you forget your rules, just make it so you don't have to do it. It's actually the same number of steps almost. So again, I would have actually added the 2x on both sides. I got negative 1. Now, is that a problem I have to worry about flipping anything? No. Can I do that pretty much every single time? Yeah, I can. So that's what I'm going to do. So I got negative 6 divide by 2. Just good old-fashioned algebra here. You get negative 3 is greater than or equal to x, right? I would have gotten the same answer the other way, because I would have added the 1 over and gotten 6. Divide by negative 2, flip my sign, and it would be the same exact answer. Okay. That's a good answer. How do I make it a great answer? Yes, sir. Interval notation. X is smaller than negative 3. There we go. Bracket, because it's already equal to. We're almost there. All right. Would you guys like to see another? So on number 3, what could you actually do if you didn't want to? We'll do 3C. I don't know why there's a letter and a number. What could I do on this one if I didn't want to divide or multiply by negative? I could add the x over, right? I could 100% add the x over and then solve it if I didn't want to remember extra rules. Okay? I won't. I'm going to do 3. I'll do 3 the other way, just so you can see it once. So I'm going to subtract my 5 over. I get negative x is greater than 5, right? Times both sides by negative 1. Because that's a negative, I flip it, right? So again, it's one less step to do it that way, but there's one less rule to remember. So I'm going to do my open circle negative 5. It's less than, add my parentheses and commas. I guess feeling at least about interval notation. Any questions on that? Bracket or parentheses? Oh, equal to or not equal to. Because an open dot means it can't be negative 5. It gets really close to it but doesn't actually become it. A closed dot means you can land on negative 5. It can be that number. We're going to deal with that a little bit more. Oh, no, we won't. If anyone takes pre-calc, we're going to talk about basic limit. Like that open dot, closed dot is going to be really important. All right. Too many crickets. I'm actually going to, I want to do number 4. I'm trying to get where I can see it better. Whatever. Just work the way I want you to work. All right. So how would you do one like number 4? I'm just going to put it up here because we have an x on both sides of the equation. Do I do anything different than what I would do if there's an equal on this one? Absolutely not. Treat it just like an equality, right? First thing I would do is I'd move over that 2x, right? Subtract over the 7. Now, when you have variables on both sides, you can always make sure your x stays positive, right? You just subtract over the smaller. 2x is greater than or equal to negative 10. Divide by 2. Ta-da.
So when do you flip the sign again?
When you multiply or divide by a negative number, it flips the sign. Only when you do it, not in the problem, but when you go through, when you're solving it, when you multiply by a negative or divide by a negative. So remember, they're the same operation. Okay, sorry. All right, so we're going from negative 5. X is bigger than it. Parentheses, bracket, comma. It makes you look smart too if you're writing it like that. If you look at like chalkboards and stuff in movies and TV shows, there's usually some interval notation floating around in it. I am the guy who will read the math in like TV and movies and make sure that's accurate. It drives me crazy when it's not. Because legit, you could just like ask Google, like, give me a math equation that looks complex. All right. I'm actually going to skip this page for right now because I don't want to deal with fractions. We're going to do compound inequality. So we're on the back of the second page. And then I'm going to go freestyle for about 10 minutes. All right. Oh no, Mamma Mia, what's this? There's 2 signs. When I go to solve this, I do have to do something different with this. How many things do I have to keep balanced here? 3, not 2. So when I go to solve this, my first step would be to subtract 2, right? Now remember, whatever I do to one piece, I have to do to every single piece, right? To keep it balanced. So it'd be like if I lined up 3 people and they each had different amounts of money in their wallet, and we lined them up by who had the lowest and who had the most. If I give everyone $10, would it change the order, or would it still be accurate? It'd still be accurate, right? Because if I subtract 2 from every part, that inequality will still be true. Okay? So I get 1, it's less than or equal to 2x, it's less than 6. Same thing. If I cut every single person in half, oh, yeah. Thank you. I was too excited. If I divide one part by 2, I divide every single part by 2. Everything is divided by 2. I get 1/2 is less than or equal to x is less than 2. These are technically and problems, but you don't have to write an and symbol because it's going to be in there automatically, so you don't have to worry about that. If I have one like this, where x is in between, my interval's already set up. Like I already have a start point and end point, right? I'm starting at 1/2. I'm going to 2. Do I include 2? No. Do I include 1/2? Yes. So these are the ones you already have it in interval notation, pretty much. And if you want to graph it, it would be 1/2. You're starting at 1/2. You're going to 2. On the homework set, I asked for both answers. Yep, you need both of them.
You make the homework problem?
I do not actually. I told you guys, Midmish, they make it so everyone's doing. So if you have 4 different teachers, everyone's getting the same curriculum. It's actually a pretty smart way to do it. Make sure everyone's on the same page. All right. I'm not going to give you one like that, okay? You're not going to have one like that. Those actually have you split into two parts. Go ahead, pause the video to make video. I want you guys to try that one. Give that one a shot. Give this one a try. See how y'all did? So first step, add 8 to everything, right? I got 12 is less than 2x. It's less than or equal to 18, right? Divide everything by 2. 6 is less than x is less than or equal to 9, right? Is that already set up in interval notation? Yep. All right. We good on those? If that's the only thing that was on the test, would you all be content? All right. I'm going rogue now. So again, you can throw this on line sheet paper. I guess there's space on this. I do want to show you something wonky that can happen. It's the same thing with equalities. Let's say you ended up with 3x is less than 3x minus 5. Okay. So I'm going to subtract my 3x over, right? And I get 0 is less than negative 5. So my x went away. What a delight that would be. Never mind, I digress. So my x is gone. Same thing as it with equalities. If there's an equal, is this true? Is 0 less than negative 5? No, 0 is bigger, right? I'd rather have $0 than $5 negative, right? So this is not true. If it's not true, I have no solutions. Okay? So the same thing is true with these as it is with equalities. If I lose my x and it's not true, there's no solutions. If I would have made the equation the opposite,
Wait, I got a question.
yeah.
That's kind of behind you that name I know about. Are you subtracting 3x or
3x, because there's a 3x on both sides. So I need to move.
Okay.
I'm trying to move all my x's to one side. You know how?
Okay.
So
there's another inequality symbol. If there was, would you just?
I would do it to all 3 sides.
Just the 3, not the 3x. Not the whole x.
No, that 3x. 3x would have to go. Are you talking about if there's like 3 inequality?
There's an inequality right there.
Then I would have to.
You subtract 3 or 3x.
I would do for okay. This one you aren't going to see one like it, but here's why I would do 3x, because it'd get rid of x on 2 of my sides, and I'd be left with x on just one side.
You have to.
Yes, you need to make sure the inequality you have a variable only in one piece, but you won't see one like that.
Okay.
So on this one, I got 0 is. Oh, hold on, I meant to do that. So this one I got 0 is less than 5. Is 0 less than 5? Yeah. So will this equation work for any number I plug in? Yeah. So it's all real numbers, or negative infinity to infinity, or I can write all real numbers, or infinite solutions. All these things mean the same exact answer, okay? On the homework, you're going to put R, right? R means real solutions, all real numbers. So if it's true, it's all real numbers. If it's not true, it will never work, okay? True always works. Not true never works. Math is one of the only times you can speak in absolutes. I think I gave you guys advice there. All right, so that was one thing that's going to come up. Here's another thing that would come up. This is actually very similar to one. What if I did that and then did this? I think I put 18. Or x plus 4. I put there. All right, I can go. Okay. So this is an or. If I affect this equation, do I have to do it to that one? No. Treat them independent of each other. Treat them like two separate things. So pretend like the or is not even there. Just solve both, and then that's going to be your answer. Okay? You're going to have two parts to it. So good old-fashioned add 6 to both sides. My algebra one's showing. Ooh, could I have added that 4x over if I wanted to not deal with that? Yeah, I probably should have. But it's too late now. I can't erase this. Uh-oh. Divided by a negative. Flip it. Flip it. Pop it. Divide by negative. Flip your sign. Or, what do I do to this one? Subtract 4, right? So that's good. That's really good. Is it great? No, it's not great. How do I make it great? Yeah. Use the symbol and put it in this interval notation, right? So this one's going to be negative infinity to negative 6, and it includes negative 6 because of or equal to. That's and. That's and. That's or. You'll never have to use and in here, but the way that's and because it makes an A. That's or because it looks like a canoe, and you need an or for a canoe. Yeah, I did actually, the canoe one. I thought it was life-changing when I did, but whatever. All right. Or kayak, depending on whatever floats your boat. Mine's the Archimedes principle of buoyancy. Is it? All right. All right, good talk. So really, when you see an or, you're just solving two different problems, okay? If you know how to do that, you're going to be just fine. When you see the or, just solve each independently, and you'll get your solution. All right? I got one more thing to show you guys, and it's going to be relatively quick. We're actually doing very well for time today. As long as there's no announcements or anything either. Yeah, if you want to. So how do I graph inequalities? Like graph linear inequalities. So like if I want to graph y is greater than or equal to negative 3x plus 4. So this is different than anything we've done because it has an x and a y, right? But if I made that an equal sign, it'd be just like what we just did. So when I go to graph it, I'm going to do this without graph paper. It's not advantageous. I don't feel like putting it up. All right. If I were to graph y equals negative 3x plus 4, you guys remember where to start? We could make a t-chart, right? Remember we did that, plugged them in. That works. You could plug in negative 1, 0, and 1 and get your points. You guys want to do it that way or do it the intercept slope way? Let's do one of each. We'll do one of each. What's this thing give us? Yeah, so I go 1, 2, 3, 4, put a dot. This is my slope or rate, depending on. So I'm going to go down 3, 1, 2, 3, over 1, right? Is that all I need to draw a graph? Yeah, 2 points make a line. Now, I drew that. I should have told you why I drew it. Oh, if it's greater than or less than or equal to, it is a solid line, right? When I graph it. Because it can be on that line. If it is like just greater than or just less than, it is a dashed line because it cannot equal it, right? So for this one, I drew a solid line because it's or equal to. Now, I need to shade a side of it too. I need to shade. You guys kind of remember that? Crosshatch you get too. If y is greater than, I shade above. So here's another. If it's y is greater than, equal to, or greater than, you shade above. Right? If it's y is less than, or equal to, or less than, shade below. Right? So for this one, I'm going to shade as high up as I can, right? Now, let's say I forget how to do that. You can do something called test point. And here's what I mean by test point. I take the point 0, 0, and I plug it into my equation and see if it's true or not. So I plug in 0, 0. So I say, is 0 greater than or equal to negative 3 times 0 plus 4? Is 0 greater than or equal to 4? No. Heck no. No. So will this graph be shaded on the side with 0, 0? No. If that was a yes, I would shade the side that's 0, 0. Is that true for, if I'm graphing inequalities in like a pre-calc class and there's like a quadratic, can I test point to see where to shade? Yeah, that's actually what a good way to do it. Plug in 0, 0. If it's true, you better shade it. If it's not true, it's not shaded. Sound good? All right, let's do, I'll leave that up there. Test point, that does come up in the homework. It'll ask you if 0, 0 is on the graph. Plug it into the inequality, see if it's true. Yeah. All right, let's do another graph. Let's do a trickier one. You'll never guess what I'm going to do this time. A less than negative 1/2 x minus 3 All right. So y-intercept, negative 3, put down. Now for this one, my slope, my shloop, oh, this one's not going to have 0, 0 on either. My slope is negative 1/2. So I'm going to go down negative 1 and over 2, right? That's my directions. So down 1, over 2. How many points make up a line? Now when I go to draw this beast, am I putting in a solid line or a dashed line? Dashed. The dashed line is y bigger than it or smaller than it? Well, let's pretend like I'm not even going to look at that. I'm just going to test point it. Let's just test point it. So I'm going to plug in 0, 0. And I'm going to do 0 is less than negative 1/2, 0 minus 3. So 0 is less than negative 3. Now remember, negatives are smaller than 0. Is that true? Nope. If it's not true, am I going to shade on this side? No. But this side, it would have been true. Okay? That's what I got today. Oh no.